So in this recording, I'm going to provide a brief overview of sediments and sedimentary rocks. And these are important to understand because the majority of Earth's sort of surface bedrock, either outcropping on the Earth's surface or, if you dig, deep enough into, the overlying soil, what you'll find first is sedimentary rock. Think about 75% of the Earth's surface bedrock is a sedimentary rock. Obviously, not in the interior, that's mostly igneous and metamorphic stuff, but the very, very thin top part of Earth's very thin crust is sedimentary, so it's often what we have the easiest access to. So as we'll go over in later workshops, sediments are formed at the Earth's surface through many different processes of weathering, which is, breaking up larger materials into smaller materials. Erosion, this idea of, picking up those materials and setting them into motion. Transport, which is taking those now in motion materials and moving them somewhere else. And deposition, which is dropping them off somewhere. And these depositional environments are especially important because these are the ones where sedimentary rocks are formed. And if we look at the diagram on the right, there are several different, types of sedimentary environments that will form different types of sedimentary rocks. And these can broadly be distinguished into the sort of continental environments, over here, Aeolian, alluvial, glacial, and the oceanic environments. So like the littoral and shallow marine here, as well as the deep marine environments. And once these sediments are deposited somewhere, they then need to be lithified or turned into rock. And this happens through either the process of compaction to make it solid, cementation, so adding some sort of cement, like, for example, a calcite cement or a silica cement or an iron oxide cement to hold the different particles together, or some combination of these two. And that will turn the loose sediments, think sand grains or, bits of silt and clay, or maybe even larger stuff, into sedimentary rock. And sedimentary rocks can be broadly classified into three different categories based on their composition. And those are clastic, chemical, and biogenic. Some people use slightly different variations of these categories, but we're going to go with these ones today. So starting off with clastic, this is really dealing with rocks that are made up of fragments from older rocks of all types, or perhaps mineral fragments if it meets our definition of a mineral from earlier. And then you take all that stuff, deposit it somewhere, and then lithify it through compaction and cementation. And clastic rocks can be, in and of themselves, classified, in several ways. Most commonly, it's based on size. So you can see the chart below. So size of the individual grains. So if we have fine stuff like clay, we can have a shale or a mudstone, depending on if it has laminations or not, if it has layering. We can have siltstone for still fine stuff, but not quite as fine as the shales or mudstones. Sandstone, these feel a bit gritty to the touch. And again, this is based on size alone. So you could have like a quartz sandstone, probably the one you're used to thinking of. But you can also have arkose, which has more feldspar in it, other lithic fragments. And then you can also have wax or gray wax, which are sandy in texture, but also have a lot of silt and clay in them as well. So they have like a dirty matrix, as it's called. And of course, you can have, rock fragments that are even bigger than sand. So you can have conglomerates, which have sort of big rounded fragments in them, as well as breccias, which have angular fragments in them. So many different types of clastic sedimentary rocks that can be often first grouped by grain size, but you can also look at things like the composition of the grains as well as the roundness of the grains, depending on sort of what grain size you're looking at. The other great thing about clastic sedimentary rocks in particular is that they're very useful for studying past depositional environments. So you can use them to determine what environment it was deposited in, whether it was a dune or somewhere in the near shore or something like that. And they also, like other types of sedimentary rocks, have good potential to preserve fossils, which can tell you about the paleo environment in your area. So the next type of sedimentary rock is the chemical sedimentary rock. Chemical sedimentary rocks are created when you have a solution with some dissolved ions in it. The easiest example is salt. And if you ever put a lot of salt into water, you'll find that beyond a certain point, if you keep adding more salt, no matter how much you stir it, it won't dissolve. It's reached its saturation point. And this can happen in nature too, when you have like a pond with some dissolved stuff in it, and then that pond evaporates, like the picture in the bottom left here, and that leaves behind these precipitated materials, which are chemical sedimentary rocks. And it's also important to note that you don't have to evaporate the entire pond completely dry. You just have to reach that material's saturation point. So you'll see on the diagram here that different types of, ion pairs have different saturation points. So calcium carbonate, or chemical limestone, has the sort of highest saturation point, so it'll come out of solution first. This is followed by rock gypsum, as then later on by halite or rock salt. Halite being the mineral and rock salt being the rock. So these will come out of solution at different times. You can see two examples here. This is a chemical limestone, and we'll discuss biogenic limestones in the next slide. And this is halite or rock salt. Another important thing here, this pond thing we were looking at earlier, which is producing evaporites. This is a landform known as a sabkha, which is not very common here in Canada, but in more arid coastal regions like in North Africa or the Arabian Peninsula, you do get the production of these evaporites in the modern day. So our last type of sedimentary rock is our biogenic rock. So this is sort of the catch-all. They don't fit into the other two categories because they are derived from biological material. And sometimes biogenic rocks are broken into subcategories like organic or bioclastic if they're made of fragments like clastic rocks, but of biological origin, like if you have a bunch of shells cemented together. But we'll just use the broad term biogenic in this case. So a couple examples are, coal is a common example where you have heat, and with the right sort of temperature and pressure and time, you can get the formation of different grades of coal. So depending on the exact conditions, you start with low grade like brown coal, lignite, then you have bituminous coal, and then the high grade stuff, which is anthracite. So different types of coal you can get, and then you can have limestone that's formed through purely chemical processes, but it's also very common to have fossiliferous or biogenic limestone where, different types of, calcite containing marine organisms are formed into these limestone rocks. So that was a brief overview of different types of sedimentary rocks.